Myself Dr. M. Ayyappan, Assistant Professor, Department of Electrical and Electronics Engineering, NPR College of Engineering and Technology, NATHAM. So today we are going to discuss about the topic Introduction of Power System. So before enter into the topic, learn some basics. What is meant by power system? Why we go for modern power system? So these are all the informations were discussed in the introduction sections. So in that first one, system planning and operational controls. So the first one, power system. What is meant by power system? Why we go for power system? So the power system, it consists of generation, transmission and distribution. What is meant by generation? What is meant by distribution and transmission? So the first one, generation. Generation is nothing but generating the power from the grid. That means what? Entire overall power it will produced in that grid only. So you are generating the power from that grid. So generation of the power from generating station, that is called as generation. And the second one is transmission. What is meant by transmission? Transmission is nothing but transmitting the power from transmission stations into distribution centers. Okay, and the next one is distribution. Distribution is nothing but distributing the power from various load, that means various consumers like domestic customer or industrial customer. Based on that requirement, the power it can be distributed from the various region. And the next one is load. Load is nothing but static load. That means static load is nothing but constant load. If you are providing the constant load to the various consumers like domestic or industrial. So in that first one, power system and modern power system, what is the difference between these two? Number one, power system it consists of only for the generation, transmission and distribution. In that modern power system, it can be additionally included for static load. So the only difference between for power system and modern power system is static load. So and the next one is components of power system. The two different types of energy like electrical energy as well as mechanical energy. In that generator, it will consider for mechanical energy is converted into electrical energy. So that is called as generator. And the next one is motor. Motor is nothing but electrical energy is converted into mechanical energy. And so in the basic section, transmission is transmitting the power from transmission station into distribution center. So actually how the power is transmitted? Through this transmission line only the power is transmitted from transmission station into distribution center. And the next one is two winding power transformer. What is the meaning of two winding power transformer? So the two winding is it represents one is the primary winding and the second one is secondary winding. What is the use of transformer? Transformer is nothing but the energy it can be transferred from one station into another station, or the energy it can be transferred from one place into another place. So the transformer definition is energy transfer is made. So that means two winding power transformer is nothing but if you are generating the power or energy is transmitted from primary winding into secondary winding. So the entire energy it will directly transmitted one to one. That means what? Primary winding into secondary winding. And the next one is current transformer. What is the use of current transformer? Current transformer uses that. So the protection and measuring purpose only your current transformer is used. So the entire power is directly transferred from through this transformer only, through this potential transformer only. And the next one is circuit breaker. So what is the use of circuit breaker? Circuit breaker is nothing but the circuit breaker is placed in the electrical substation. If any of the fault is occur in the same, if any one of the region or any one of the place or any one of the feeder means at the time your circuit breaker is operated. So the reason circuit breakers are used in that India, SF6 circuit breaker or vacuum circuit breaker. Majority if using in the SF6 only, is used in all over India. So, the major purpose for using the circuit breaker means the small and the large disturbance if occur in the transmission line or any other different region or any other different feeder means at the time the automatically the circuit breaker is opened. So, based on that circuit breaker open and closed contact, your power, that means your shutdown process, it will be made in the same substation. So, next one is fuse. So, yeah, in all the power system or all the electrical components, the fuse is must. So, and the next one is load. Already I will explain the same informations load in that static load or dynamic load. What is the difference between these two, static and dynamic? One is the stationary and the second one is the variable. So, variable load is nothing but based on that requirement your load is adjusted, that is comes from that dynamic load. Your stationary load or static load is nothing but your load is constant in the entire period. And the next one is functions of power system. In that functions of power system, first one is the monitoring process. Monitoring for what? So, your bus voltage is monitored. So, your bus voltage is monitored means your real power is monitored and reactive power is monitored for the different connecting various transformers or various lines or various feeders is connected through these buses only. So, entire buses in the voltage is monitored in the monitoring process. That means what? Real power and reactive power. So, the two different system is connected in that particular bus only. In that particular buses, if monitoring the specific voltage means the specific system working in a right manner or not, that is to be defined in the based on that monitoring process. And the next one is designing the system. For designing what? Designing the circuit breaker. And the next one is planning for future expansion. Planning for future expansion is nothing but for the initial time the electrical substation is commissioned. That means the overall entire construction is defined in that starting period. Suppose we go for the next stage means the old system it can be replaced in a new one. That means what? Your construction, your commissioning is only for the planning for future expansion. Your construction is made for what? Future expansion. And the next one is analyzing the network. Analyzing the network is nothing but so the various power system components and the various different types of networks are configured. At the time, if you are going to the particular power system network is analyzed means at the time your entire bus voltages as well as real power, reactive power, different machines are two different machines, it will connected on the same through this bus means what will happen in the particular system or particular network. The entire system is analyzed. That means based on that analyzing only your specific power system network it can be extracted. And the next one is stability analysis for various disturbance. What is the reason for go for that stability analysis? Whether the system is working in a right manner or wrong, or otherwise the particular system it providing the right voltages or any other misleading voltage or lagging voltage. So, all those informations how it will refer means the based on the stability analysis only the particular system is analyzed. So, in that stability system various disturbance is referred. Various disturbance is nothing but small disturbances as well as large disturbances. And the next one is single line diagram. So, the single line diagram is nothing but so overall entire process, that means entire power system operation process it comes in the single line diagram. So, the first one is generating station. In the generating station generating the power from the grid, and the next one is primary transmission. So, 11 kV bar 132 kV step up transformer. In that primary transmission side the 11 kV is stepped up into 132 kV. So, in that process your voltage is step up to the process. So, what is the meaning, what is the reason for step up and step down processing in that power system operation? If any of the voltage is leading or lagging, particular system is working in the based on the requirement of voltage, your voltage is to be adjusted through this step up and step down process. In that first one, primary transmission, your voltage is step up, like 11 kV is step up into 132 kV. And the next one is in that same receiving station, 132 kV again step down into 11 kV in the receiving station. So again, so this is 33 kV bar 11 kV is nothing but electrical substation wise it will be divided, like any of the consumer, the basic domestic consumer are referring 11 kV, or any other industrial are referred in the 33 kV. Based on that requirement, the electrical substation is divided into 11 kV or 33 kV mini substation. That means what? Some subdivisional electrical substations. Like 33 kV is separated and 11 kV is separated. In that process, 11 kV again converted into what? 33 kV is converted into 11 kV. In the substation wise, in the distribution transformer, whether it is 33 kV or 11 kV, is distributing the power to the various consumers like 11 kV or 415 kilovolt. So based on that requirement, the 11 kV is supplied to the consumer or 415 kV is supplied to the consumer. This is requirement of the application or requirement of the consumer. And the next one is power system analysis, infinite bus bar. Infinite bus bar is nothing but the two different system is connected through this bus. Infinite bus bar means the specific voltage or required frequency is constant in the infinite bus bar. So all the power system components or all the power system operation, it will be worked based on the voltages and frequency. That means your infinite bus bar system, your frequency and voltage is to be kept constant. And the next one is phase analysis. Phase analysis is nothing but phase. What is meant by phase? Actually, the three phase it refers that R, Y, B. R it represents first, that means a single phase. Y it represents the second one, and the third one is B. So the three phase it refers R, Y, B supply. Each and every individual phase it represents 120 degree of phase shift to the one phase into another phase. Like for the first phase, 0 to 120 degree for the first phase. Again 120 is added 240 for the next phase. And the third one is 240 into 120 plus 240 plus 120 into 360. So the three phase is referred 0 to 360 degree. That means each and every individual phase it represents 120 degree of phase shift to the another phase. So what is the reason for go for that phase analysis? Phase analysis is nothing but individual phase voltage is analyzed. Based on the individual phase voltage analyzing, the remaining phases are not calculated. Like if you are going to calculate it with that R2Y means your R2Y is 120 degree. Okay, no problem. So the remaining phase is also what? 120 degree. And the remaining the third one B2R is also 120 degree of phase shift. So that is not necessary for calculating all those phases. Only it will calculate for the single phase. How it will differentiate single phase and three phase? Three phase is to refer that ROB supply as well as plus neutral connection. Single phase is nothing but one phase and one neutral connections. And the next one is per unit value. So per unit value it represents actually the overall power system value, the results, the impedance value is calculated in the per unit calculation. So what is the reason for calculating the per unit calculations in the single line diagram or any of the power system components? So the overall system it will not calculated. So if you are calculating only the single unit means the entire system output is it comes from the same way. So finally we can calculate only in the single unit. So this name is called as per unit value. And the next one is per unit system. Per unit system is also what? The entire system, the entire per unit value is calculated in the power system network. The overall system, the value is calculated through this power system network. So, based on that power system network, it represents per unit system. And the next one is base value. So, what is the meaning of base value? How it comes base value in the power system network? So, like when I will tell you one simple example. I am telling one simple example like some 11 kVA generator and 20 MVA generator. That means the same 20 kVA and 11 kVA and 20 MVA is processed in the power system network, means reactance output is different. Some outputs it will shown in the final stage. Suppose if you are giving the two different values, your base value is changed. 11 kV is changed into what? 5 kVA, and 20 MVA is changed into 10 MVA. Suppose if you are giving the 5 kVA and 10 MVA, means what will happen in the power system network? In that case, it will referenced value is called as base value. Okay. And the next one is equivalent circuit of power system components. Equivalent circuit is nothing but actually in the single line diagram or reactance diagram, all those values are calculated like base value or actual value and the per unit impedance value. All those values are calculated, means finally it will draw one equivalent circuit. So, the equivalent circuit it represents some conditions. Based on the conditions only we have to draw the reactance diagram or single line diagram. In that generator, means one resistance is present and the inductance is present and generating E, that means EG, generating EMF, that means plus or minus. So, finally if you are drawing the generator, that means generating a generator for the equivalent circuit, means this symbol is used in the final stage. And the next one is same as like that motor. So, EM is nothing but motor, generated EMF of motor plus and minus, the same as like that resistance and inductance is presented. And the next one is transformer. So, the transformer it represents primary as well as secondary. So, on the one side of resistance and inductance is present, and the right side is also one resistance and inductance is also present. Suppose if you are any of the any of the connections or any of the power system network, some transformer it will present, means finally if you are drawing the equivalent circuit in the transformer parts only using the same diagram in the reactance diagram or single line diagram. And the next one is actually the in that transmission line it consists of two different types. One is the pi representations and the second one is the p representations. Pi representation is nothing but the two capacitance are presented like in the left hand side as well as right hand side. In the middle side resistance and inductance is also present. Suppose we go for that T representation, means only the single capacitor is present, as well as the same in the right hand side resistor and inductance, and the same as like the right hand side resistor and inductance is also present. How the name it comes? Pi representations and T representations. Pi and T representation it will shown in the schematic way, like the pi representation it will the diagram the same pi it will be what graphical or schematic representation, the symbol or the diagram it shown as like that pi. Finally, T representations is also the diagram it shows like that the symbol of T, that means T representations. And the last one is load, static load. Static load already I am telling the same information. Static load is nothing but the load, the individual voltage or the specific load or requirement of the resistive load or inductive load is what? Constant or the stationary one. So, if you are giving the constant voltage or constant power, it will be providing on the secondary side. So, this is the basic operation for a power system. Thank you.